Have you ever just stopped and thought about how the internet actually works? I mean, how do billions of different devices, made by thousands of competing companies, all talk to each other so perfectly? How does your Apple iPhone pull up a web page from a server that's running Microsoft Windows? Well, the answer is surprisingly simple, and it all happens at the very top of the internet structure, a place we call the application layer. Let's get into it.
Now, to really get what the application layer is all about, you've got to appreciate the journey to get there. The best way to think about it is like climbing a mountain. We've just traveled through all these complex, super technical lower layers of the network, and now, finally, we're at the summit. This is the part that we, as users, actually see and interact with every day. So before we kick back and enjoy the view from the top, let's just take a quick look back at the path we climbed to get here, to this final and, you could argue, most important layer of the internet. You know, our whole climb started way down at the bottom, with just raw electricity and pulses of light zipping through a cable. That's the physical layer. Then we moved up a step, giving our data a local address with MAC addresses, then a global address with IP addresses, and then we made sure it got there reliably using TCP ports. See how each step adds a bit more structure and order? It all leads right up here, to layer 7, where all that technical stuff finally becomes the actual content we wanted in the first place. And here we are. We've made it to the summit, and the view is amazing. It's a whole world filled with every app we use. But this view also reveals a massive challenge. It's kind of beautiful chaos. See, up here at the top, our data finally becomes what we actually care about, the payload. It's not just abstract ones and zeros anymore. It's the good stuff. It's the Netflix movie streaming on your TV, it's the words on the web page you're reading right now, or the document you're about to print. This is the payoff for that entire climb. But here's the catch. Down in those lower layers, things were pretty simple. Pretty much everyone uses the same stuff, like IP and TCP. But up here, the application layer is like a huge, bustling city with an infinite variety of programs. You've got tons of different web browsers, countless game clients like Steam or PlayStation, all sorts of email apps. It's a wild, chaotic landscape. And that brings us to the central puzzle, the real head-scratcher. How in the world do you get all these different programs to talk to each other? Let's be specific. How does a web browser made by Google, like Chrome, successfully talk to a web server running software made by its biggest rival, Microsoft? I mean, they weren't designed to work together, so how does it all just work? Well, the solution to all this chaos is actually incredibly elegant. It's not about forcing everyone to use the exact same program. No. Instead, it's about getting everyone to agree on how they're going to talk. It's about creating a universal language. And this universal language has a name. It's called a protocol. That's all it is, really. A protocol is just a set of rules, a shared vocabulary and grammar that different programs agree to use when they talk. It's kind of like if two people from different countries agree to speak English to have a conversation. It's the common ground that makes communication possible. I mean, just look at the difference this makes. In a world with no protocols, you get total chaos. Every program is speaking its own language, and the internet, as we know it, well, it just wouldn't exist. But with shared protocols, we get order. It doesn't matter who made the software. As long as both sides agree to speak the same language, the conversation just works. Okay, so let's make this real. Let's look at this in action with the most common protocol out there, one that you use every single day, probably without even thinking about it. Let's talk about the protocol that powers the entire World Wide Web. So for the web, here's the breakdown. On one side, you have the client. That's your web browser. Could be Chrome, Firefox, whatever. On the other side, you have the server. That's the computer where the website you're visiting lives. And the universal language they both agree to speak is HTTP. That stands for Hypertext Transfer Protocol. Your browser uses HTTP to ask the server for a web page, and the server uses HTTP to send it right back. It's that simple agreement that makes the entire web go round. And this is the real magic of having a standard like this. Because HTTP is an open, universal protocol, you have total freedom. You can delete Chrome right now and install Firefox, and the web will work exactly the same. The server doesn't care what browser you're using, not one bit. All right, so let's bring it all home. Let's focus on the big takeaway here. Why does this whole idea of protocols really matter so much in our digital lives? This quote just nails it. The server doesn't care who you are, only how you speak.
Protocols create a perfectly level playing field. It's not about what brand of software you are, it's about whether you follow the rules of the language. And that simple principle is what makes the internet such an open and amazing platform. So if you're going to remember 3 things from all of this, make it these. First, the application layer is that top level where your software actually meets the network. Second, the payload is the good stuff, the data you're actually trying to get. And third, a protocol is that universal language, like HTTP, that makes it all possible. And that leaves us with one final thought to chew on. We've talked a lot about HTTP, but these protocols are literally everywhere. They run our email, they run our file transfers, they run online gaming. So the question I want to leave you with is this. What other universal languages can you think of that are quietly shaping our digital world every day?